Okay, in this video we're going to go through the tutorial Takeoff CAD file from start to finish. The purpose of this is to get cut fill quantities, material quantities on subgrades. We're going to do topsoil removal replacement. We're going to look at the 3D drive simulation, cut fill color map, and some other cool things along the way. You can follow along if you go to the help menu, and all these steps are written out. And if you go into File, Open, under CARLSON projects you should see either Demo 1 or Takeoff Demo 1, and that's the file that we're going to use. I'm doing this in CARLSON Construction, but it can be also done, all these routines are in CARLSON Takeoff and the SiteNet pull down in the Civil. So starting out, I'm going to go into Takeoff and look at my project checklist. And this gives me a list of the 5 steps I need to do, absolutely have to do, in order to get quantities. So I need to define the layers and which target those are. Are they for the existing or the design? I'm going to set a boundary polyline, my limits of work, and then I'm going to make an existing and design surface, and then using those surfaces we can calculate total volumes. If I go up to Takeoff, I can see a lot of those commands are in here. I'm working kind of top to bottom through this list to get to calculate total volumes. I also have a toolbar here with these same steps going left to right. If you don't have this toolbar shown on the screen, you can right click, and the 2 main ones that we're looking to use are Takeoff General, Takeoff SiteNet Display, and some other useful ones are Inquiry, Layers, Polyline, and Standard. So you can go through and check those on and put them anywhere on the screen. So that's just right clicking to get an option of what toolbars are shown. I'm going to use mostly toolbars. It's just a little faster to run the commands and get familiar with the toolbars than having to go up to the menus all the time. So under project checklist, this first step, define layer target material subgrade. If we run that command, so it's right here, I can see a list of all the layers that are in this CAD file, and I'm going to set these layers. I'm going to tell the program that they're either design existing or design elements, and I can pick them from this list here. So proposed face of curb seems like a design element to me, so right below here I can say move to design. I could also say, here's proposed elevation. Let's move those 2 elements to design. So I'm telling the program that this is important information for my design model. I need to do this for the existing as well. But a lot of the times the layers that you're given, you might not necessarily know if those are existing or design elements. So I'm going to say save here and exit out. And the first command I'm going to run is right here on the right, called Drawing Inspector. This is also under Inquiry. If I run Drawing Inspector and I go over any entity, it's telling me on the first line there what layer it's on. So I can see this layer is on pad, and if I go over here, here's proposed face of curb, and if I go over this line, it says intercontour. To get this information shown, if I right click, you can see I have layer name checked on, entity type, and display elevation. So that's telling me the layer. I can see this line is actually elevated at 817, and I can see something like my building pad is at elevation 0. But what I'm doing here is looking at the layer names that different things are called. Okay, I can see this is a design element, my building pad, so I can come up here and say set layer for design. I could also do this under Takeoff, is set layer for design. But I'm going to say, okay, this is a building pad. I have labels and a curb line, and I'm going to press enter. Okay, and it says it set these layers to the design surface. So if I look at my list here, I now have these 3 layers under the design. And I can do the same thing for the existing. I can say set layer for existing. I can see these contours here, and I'm going to highlight those and press enter, and it moves those layers into the existing surface. I don't have to pick on every single contour. As long as the contours have the same name, it will grab everything that's on that same layer and put it to the existing. So if I check my layers again, I now have layers for existing and design. Okay, so we're starting to build and tell the program what we want to do or what layers to use to make 3D models. We can see we still have a lot of layers under here. And just to visualize what we've done, I can turn off the design and existing and other as I wish and change what's shown on the screen by the list that I have here. So if I exit out of here, I can say, you know what, don't show me the other. Everything that's on that list for other gets turned off, and likewise I could say turn off design. So right now I'm looking at just the layers that I've defined as existing. Those look pretty good. I can look at the design as well, and I could turn off the existing. Okay, this looks like a lot of my design elements. You can see I might be missing some things, so I could turn on other and turn off the design. And here's layers that I haven't called existing or design yet, but you can see here's a finished floor elevation. I want to put that on the design. And same with this element here. I believe it's a swimming pool. I want to put that to the design as well. Okay, I have some labels out here and some other line work that I'm not going to worry about. So I can turn off other. I can look at my existing. I can overlay the design, the layers that make up the design, or I could view just the design. And by turning these on and off, what I'm basically doing is showing these different lists of layers for existing, design, and other. I'm going to exit out right now and go back up to Takeoff and look at my project checklist. So I've done this first step of setting layers to either the existing or design, and I can move on to the next step, which is setting a boundary polyline. If you're following through the tutorials, you'll see that there's a boundary line given to us. I'm going to create my own boundary. I want to go all the way out to the limits of this existing, so I'm going to create my own. And I'm going to do that by going up to Draw, and I'm going to run a command called shrink wrap entities. And what this command will do is act like a rubber band around everything I select and draw a line work around there, so I don't have to manually click through all these points to create a line. So I'm going to say OK to the defaults here. It's going to be on a layer called Limit of Works. And it prompts me down to the command line Select Objects. So I'm just going to window around all my existing and design and press Enter. And you can see it's now drawn a line called Limit of Works going all the way around my job. And then I'm going to set this as the boundary polyline. So we first defined existing and design, now we're saying set boundary polyline, and I click on this line. If I go to Takeoff Project Checklist, I've now done my second step of setting a boundary polyline. Moving on, you can see my next step is making the existing ground surface. So I'm going to say OK to this, and I'm going to turn off my design and other. So I'm looking at just the existing, and I can see things have elevation. If I zoom in, this says 818, and that matches the label. Just want to make sure before I create a 3D model of this that the elevations listed match their labels. I can also look at this line work in 3D if I run the 3D viewer window. I just click on this icon, select the objects, and press enter. And now I have a 3D window of my existing. I can tilt this and I can see the elevation range 803 to 822 because I have color by elevation checked on. So I can see my contours. Tilting it to the side, I don't see any big conflicts. But I can also exaggerate the scale. Let's go 5 to 1. And I can look to see if any of those contours look out of place. But the line work looks pretty good. So let's go ahead and make a model. And that's just the next icon next to set boundary polyline is make the existing ground surface. Okay, and it says done. And so what make existing ground surface does is it makes a 3D model of the layers that I've called existing from this list. If I want to look at that model, I can go to View, Surface 3D Viewer, and I'm going to click on EX is my existing surface. For Demo 1 is the drawing I'm in, and it just adds the extension EX. So the program automatically names the file for me. If I say Open now, now I have a 3D model of this surface, of the existing. Okay, likewise I have color by elevation checked on, so I can see my elevation range is from 803 to 822, and I can color this and see this model. And I'll put in a vertical scale. Okay, so my existing model looks pretty good. Let's look at our next step. I'm going to go back up to Takeoff project checklist, and I can see the next thing on the list is to make the design surface. So let's turn off the existing, turn on the design, and unlike my existing that had elevations on that second line, everything on the design is just at 2D. It has 0 elevation, and I can confirm this if I look at it in 3D. So if I say 3D viewer window, I'm going to select the objects for the design, and you can see it looked like everything was at 0, but there are some things with some funky elevations in here. Some stuff's at -3 and some stuff's at 18 elevation. And if you remember, our existing was all between 803 and 850 or so. So I have some problems here. Things looked like they're at 0, but they actually have some elevation. If I turn on ignore 0 elevations, if I uncheck that, and let's expand, I can see most of my line work is at 0, but I have this one object up here that's higher. If I go into the advanced mode, or if I click on model here, I can say, you know what, I don't need to see the text in 3D. So I can go to text and right click on this and say freeze the text layers. Okay, so I'm looking at just my line work now. This is what will make our model. The text, it doesn't matter if that's elevated or not. Okay, what matters is that the line work is at good elevation. And I can see this one is at a bad elevation. It should either be at 0 or at its true elevation. I can actually double click on this line and set it to 0 and fix this problem right from the 3D viewer. But we're going to go ahead and fix this later, just to show some of the other commands that I could use to fix this. But I'm kind of aware now, even though things look like they're all at 0, I have some stuff that's at a bad elevation. To get this line work to the correct elevation so we can build an accurate model of the design from it, I'm going to run a command commands under the elevate pull down, and I'm going to start off with set polyline to elevation. I'm going to enter a text elevation of 818.7, and that's my building pad elevation. So I'm just going to click on that line and press enter, and then I'm going to press enter to run the command again, and I'm going to enter in the elevation for this pad, which is 817.56. I'm going to hit enter again and pick on the yellow line here and press enter. Now with my drawing inspector, I can see this is now elevated correctly, 817.56 and 818.7. So this is now elevated, but I have a problem of needing to elevate the face of curb here. And if I go over this line work, I can see I can't set it all to one elevation. It's a 3D polyline. I need this line to be interpolated between all these points. But we have a command specially designed to handle this line work. If I go to elevate 2D to 3D, so I have something that's at 0 elevation, I want to bring it into 3D. And I have different options here by points, by text, and in this scenario I have text with a leader line. So I'm going to select this option, and I'm going to follow the command line at the bottom here. So it says select sample of the text, select sample of the annotation leader, and then it says select a polyline to convert, a sample of that as well. And now it says select entities to process. So do I want to process this corner right here? I could select those entities, but really I want it to elevate all the curb line in the job, so I'm going to type in all. I can see it's now highlighted both curb lines, and I'm going to press enter, and then it's now prompting me to enter an elevation to add to this value. Okay, so I don't want everything to be at elevation 16. I want it to add 800 to all these values. So I type in 800, enter, and now I'm prompted. It also recognizes that there's a top of curb elevation and an FS elevation or FL elevation given. So I'm going to elevate this line work by the top of curb. So I bring that to the right. Here's all the options I could elevate it by, but I'm elevating it by the top of curb, and I'm going to say OK. And it wants to make sure that this text is going to be used on this line right here. I'm going to say enter to accept. It says remaking 5 polylines. And now I can see if I go over this line, this elevation is at 816.8. So it's read this value for the TC, it's added 800, and it's added it to that point. And if I go along this line, I can see that elevation start to increase, and it's interpolated that elevation all the way to over here, 817.2, if I get right on that point. And it's done that between all the points, not just on this curb line, but all the curbs in the job. So if I look at this line work in 3D again, with a 3D viewer window, select my entities, press enter. I now have my line work within that range of 814 to 820. I've put this line work into 3D. It's no longer at 0 elevation. Still, I have some steps I want to do before I build a design model for this. I have the finished grade elevations, but I want to build in my subgrades for both my parking lot area and the building. And to do that, I'm going to the same place where we defined the existing design, this icon right here, and I'm clicking on the design, and I'm first going to go into my building pad. I'm going to set a color for the 3D drive simulation. So I'm going to see this in 3D. I'm going to see a red building. And down below here for my subgrade, I'm going to have a concrete pad of 1 foot. So for my building pad here, I'm dropping it down a foot of concrete. For my parking lot, if I click on this icon, I want to set a color for the 3D drive as well, and we can make that yellow. And then you see under material type, we use area for the pad. I have other options here for just getting linear footage or a count. But if you remember, when I set elevations to my curb line, I use the top of curb elevation. But I don't want to use that elevation all the way through the parking lot. I want it to actually be a half a foot below that top of curb elevation. So I'm going to use the option here, back of curve pavement. And I'm going to come into curve dimensions. And what happens with curb dimensions is that top of curb elevation I used in the drawing, it's going to call that point right here the top of curb, and then it's going to apply this curb to the inside. So you can see my height 2 is 12 inches and my height 1 is 6 inches. So it's going to use that top of curb elevation, and then 6 inches below that is where my paving is going to start. So I'm going to say OK to this, and then I'm going to come here under subgrade, and I'm going to say inside of my curb area I want to have asphalt and gravel, and I'm going to do 0.33 feet of asphalt and 0.67 of gravel. So I can work in feet or inches, and I can apply any depths that I want here, and I'm going to say OK. And now I've defined subgrades for my design. I'm going to say save and exit. And now I have my subgrades defined. I have elevations on my line work. So I'm going to try right now to say make design surface. I'm going to hit this icon here. If the program finds any errors, I get a report log. And I can say crossing break lines, show me where that conflict is. Zoom in, I'm going to say zoom to and zoom in, and it's saying right here there's a bad elevation. And if I look at this line work, here's 817, and this line that's crossing into it, even though it's a leader line, it has a slight negative elevation. So it's causing a spike in the drawing here. I can say draw one, and I'll draw an X, so I could come back and fix that, but I'm just going to say exit. And even though I know that there's a conflict there, let's look at the 3D model for this. So under View, Surface 3D Viewer, I'm now going to pick on my FN, which is my finished surface of the design drawing. And if I look at a model for this, I can see I have all sorts of errors. My elevation range starts out at 820, but I have bad elevations that is causing these spikes in the model. So if I were to run quantities right now, I probably would have a lot more cut than I'd be looking for. So let's quickly fix these bad elevations that are affecting my model. I know where one of those is because it's crossing a good elevation line, but I don't want to have to go through and find all those bad elevations. What I'm going to do now is run a command that I could have ran at the very beginning when I opened up this drawing, but I'm going to run it now. It's called drawing cleanup. And I guess there's two different approaches of using drawing cleanup. You can run it at the beginning to try to clean up a lot of the bad CAD that you could have in the drawing, or you could wait to see when you have a problem and run it when you're confronted with that problem. And you can see all the different options that are in here. This command just takes, is running 20 things at once to try to clean up a lot of the common errors that you might find in a drawing. So it's going to remove duplicate line work that you might find in a drawing. You see that there's join line work with the same endpoints. An example of that is with our existing. If we look at these existing contours, you can see that these are all broken into little segments. It's not one continuous line. So what that routine and drawing cleanup will do is join these into all one continuous line. We didn't need to run it at the beginning because we still made a good existing model. But if these elevations were at bad elevations, running drawing cleanup would connect these into one line that I could then fix the elevation for. So let's run drawing cleanup. And there's a lot of commands I could run. I'm just going to run a couple of them. I'm going to do converting all these other types of AutoCAD entities into polylines. I'm going to say join line work with same endpoints. And to fix those bad elevations we saw in our design model, I'm going to say set elevations outside range to 0. If I check that on and I say scan DWG, I can see the elevation range it came up with. So 822 is the largest elevation or the highest elevation I have in the drawing, but I have some stuff in here that's at negative elevation. That's obviously incorrect. I'm going to say, really there shouldn't be anything below 750 feet in elevation in this drawing. And what this will do is those things that were at negative or anything that's outside this range, it's not going to get rid of the line work. It's just going to set it to 2D so it doesn't affect any of my models. So I can say, from 750 to 822, that's my working elevation range. Anything outside of that range, set it to 0 so it doesn't affect my models. So I have these 3 icons checked. I could run it on a certain selection set, but I'm going to run this on the whole drawing. So I'm going to say OK. And the program will run through drawing cleanup. And just like that, I get a report of what the program has done. So I can see that it's converted almost 3,000 entities that were these different type of AutoCAD entities into polylines. And I can see it's joined almost 3,000 entities into solid line work. And then what's important for our model is that it found 21 elevations that were outside of our range and set those to 0. So if I look at these existing contours now, I can see that they're one continuous line if I click on them instead of being broken up into little segments. But what I'm most concerned about is my design model. So I'm going to say remake or refresh my design model now that I've ran drawing cleanup and hopefully cleaned up some of those bad elevations. I'm going to say OK to this error log, and then I'm going to look at my design model again under View, Surface 3D Viewer, and loading my design Demo1 FN file. Now if I look at the model now, I can see I don't have any conflicts or spikes going way down in the drawing. What I do see is my building pad is dropped down correctly, but it looks like my subgrade is inverse. It looks like it's not dropping down the parking lot area correctly, it's dropping down inside of that. So let's see what might be happening with that. To double check my subgrades, I'm going to go up to Takeoff, and I'm going to say subgrade areas and hatch subgrade areas. What I want to hatch, I'm most interested in my curb because that looked incorrect. So I'm going to say draw. This should be my parking lot area. I'm going to say OK. And right away I get an error message saying there's 2 unclosed polylines for my curb. So I'm going to say OK. So I can see that it's hatched incorrectly. It's hatched to the inside and not the parking lot area. And the reason for that is that my line work isn't closed. I can see it's opened right here. So the program is using closed polylines to determine where the parking lot area is here. Since this is open, it doesn't know that this area should be parking lot. So to fix that, I'm going to run two commands. I'm first going to isolate this, and I'm going to do that using this icon here, isolate layer. This is also under view, and I'm going to click on that line. And then the next command, which can also be found under edit, is close polylines. So I'm going to run close polylines, and I'm going to select all my entities for the curve and press enter. So now this is a defined parking lot area, and it should hatch correctly now. So if I go back up to Takeoff, subgrade areas, hatch subgrade areas, and I'm going to draw the curve again, I can now see that it's hatched correctly. So this is where it's going to apply my parking lot, that asphalt and gravel that I told it. And just to double check, I'm going to say subgrade areas, hatch subgrade areas again, and I'm going to do the pad this time. So I'm going to say draw, and I'm going to change the color to yellow just to see something different. Okay, so I can see that did hatch correctly, and I can draw a little legend for this if I want. If I say subgrade areas, draw subgrade hatch legend. If I wanted to do a report of this, I can just put this off to the right here. To do a report, I can go up to Takeoff, Graphic Reports, Plan View, and I'm going to say OK. So by going to the Graphic Reports in CARLSON Takeoff, I now have created a PDF of my subgrade areas with the legend, and I have the option of creating a title box as well. So I can either save this PDF file, or I can exit out of it. To get rid of the hatching, I'm going to go back up to Takeoff, subgrade areas, and say erase subgrade hatches. If I turn off the design and turn it back on, that refreshes this line work. So now that I've closed off my line work for my subgrades and it hatches correctly, I'm going to remake my design model. And I'm going to check it out with the 3D viewer again. So Surface 3D viewer, and I'm using the design FN for my design model. And now I can see that my subgrades are being applied correctly. If I put a vertical scale on there, I can see those subgrades being dropped down. I'm going to exit out. Now I want to go back and to Takeoff and check where I'm at. Project checklist. Okay, I've done all these steps. I set the boundary. I've made my surfaces. Now I'm ready to calculate the volumes. So I'm going to go to this next icon here, calculate total volumes. I can put in a swell or shrink factor here, and I'm just going to say OK to the defaults and look at my report. So I can see on this job my cut and fill, my max cut and fill, and if there was 50 feet of cut on here, I have coordinates for where that is. If I thought that was an error, I could go and locate right on the job where that is. I have a total horizontal area, a total slope area, my average cut and fill depths, and an export volume. And that's just the difference between cut and fill. If I had more fill, I would have an import volume. This is a text report that I can type into. I could save it, I could print it out, or I could put it on the screen. So I can click screen here and say OK and pick over to the right. Another report I could look at if I go back to calculate total volumes is that same report but formatted in a PDF format. So if I say OK, now I get that same report, but in a PDF I can see my cut and fill. It's color coded, and this again is something I can print out or save. But what this report is lacking is taking into account the topsoil. I haven't applied a topsoil removal and replacement, so I don't have quantities for those, and that will also change my overall cut and fill by putting in those topsoils. So I'm going to turn on the other, which shows me my boundary, and I'm going to go up to Takeoff and say topsoil removal and replacement, set topsoil removal polylines. And it's asking me down here for a custom or define amount. I'm going to say I want to do a custom amount of 1/2 foot that I'm stripping, and I want to strip the whole site. So I'm going to click on this line work out here, and then I'm going to go up to Takeoff topsoil replacement and say set topsoil replacement polylines. And I'm going to do custom amount again. I'm going to put back 1/2 foot, but I want it to include this area here but exclude the buildings, and I'm also going to put topsoil back on the islands here. So if I select those and press enter, it's now applied topsoil replacement polylines to the lines I clicked. Just to make sure it's going to put back topsoil in the places that I want, similar to the subgrade areas, I can hatch and visually confirm that I'm going to be putting back a 1/2 foot in the right areas. So if I hatch the topsoil replacement, I can see I'm putting back topsoil in the areas that I want. It's not putting it back in the parking lot areas at all. It's excluding the buildings, and it's putting in those islands. And just to confirm my topsoil replacement or removal is correct, I'm going to hatch that as well. So I'm going to topsoil removal and replacement and hatch topsoil removal area. And I can see I'm removing all the topsoil across my site. Okay, so let's run calculate total volumes again. And the program recognizes that I've put in some definitions for topsoil, so it's going to remake these surfaces to take those definitions into account, stripping a 1/2 foot off and then putting some back in the design. And I'm going to go back to looking at my standard report. The black area is showing me where it's taking off quantities from. So looking at my report, I can see I'm now stripping topsoil and I'm replacing topsoil. And I can see that my replacement area is much smaller than the removal area. So I'm just confirming that this volume is different from the topsoil removal area. And by taking off all this topsoil, that's changed my cut fill volumes as well. So we've looked at the overall cut fill quantities for the job, but we haven't looked at our material quantities. What are the quantities of the subgrades that I'm using? So that's just the next icon here. If I click on that and I say OK, and now I get a report of, I can see my pad and I can see the volume going into that pad, and then I can see my curb and then also my asphalt and gravel going into that parking lot area. And again, this is a report that I could type into, that I could print out or save or put to the screen. And I'm going to exit out of here. Save changes to the report. I'm going to say no. So now that we've gotten quantities for our project and we've looked at cut fill quantities and material quantities, let's look at some of the visualization tools that the program has that will allow me to feel comfortable with the numbers that it's giving to me and that I could potentially show off to others. So let's go to display, and I'm going to start with the cut fill color map. So this shows me in red where my cut is and my blue is my fill. If I go to display cut fill labels now, this shows me, if I zoom in, the exact cut or fill amount plus the elevations at different points. So right at this X here, I have a proposed elevation of 817.56. The existing is 818.63, so I have 1 foot of cut. And in the blue areas, I can see the proposed, existing, and whatever the fill amounts are. If I want to drill down further, let's turn off the cut fill color map. And we're going to look at another neat command, the surface inspector. What this does, instead of just showing me elevations at different intervals, I can go to any point and it gives me the surface elevations in real time. So if I'm in my building pad here, I can see the unadjusted designs 818.7, which matches my label. I can see I'm dropping that down to the target design is a foot below, and then I can see the existing surface and a topsoil strip of 1/2 foot here. And as I change, I can see those numbers change. My elevations obviously for the design don't change inside the building pad, so I know I have that elevation across the whole pad. But as soon as I get outside of that pad, I can see those elevations change again. And if I look inside, you can see the unadjusted design and target design. There, I have a foot difference there. And inside this area, that difference is a 1/2 foot because my target design is the topsoil replacement number, which was only a 1/2 foot different, not a whole foot like our subgrades. So I can see that my topsoil replacement is being applied correctly as well. If I go inside my road area, the parking lot, I can see that that's being dropped down by the subgrade amount as well. And that command, if I hit escape to get out of it, is the surface inspector. And that's also under inquiry. Let's turn off our labels here by going to display cut fill color labels. We'll take those off. And we'll look at another cool command that we have on this toolbar, quick profile. If I run quick profile, and I'll zoom out a little bit, I can pick 2 points going across my site, and the program will give me a cross-sectional view. And I can toggle these on or off. So I can see my existing ground, I can see my design, and then I can see my subgrade adjustment being applied. And wherever I am in the profile view here, I can see where I am with the triangle there, and those match up. If I say adjust alignment and I pick on this line and drag it through the site, it updates in real time, and I could see very easily if I had any spikes going through the model. I can draw this out or save this profile, but let's exit out and take a look at 2 more commands. The first one being my 3D drive simulation. So we looked at the design model and the existing model with our standard model viewers. So with the 3D drive simulation, I can see the colors I set for the subgrades. I have my red for the building pad, yellow for my parking lot area, and I can see it's applied those subgrades correctly. If I like a particular view, I can hit save to PDF, and it'll create a PDF file of that image and the view that I'm looking at. I can hit run, and drive along the job, use the arrow keys to move left and right from my keypad. I can change the views that I'm looking at. I have different little vehicles that I can use to drive around. I can be a person running across the site, and this is not only a good tool to check the 3D model or to use in presentations. I can also do some neat things like pick on any point and draw a marker symbol. If I say draw marker, if I thought there was a spike or some sort of conflict here, I can say draw marker. And when I exit out of the program, it draws a circle for wherever that location is, and I could go back and fix that if I thought there was a conflict there. That's our 3D drive simulation. The last thing we'll look at now that this job is complete is sending this information to Google Earth. So if you look at my coordinates, I need to be in state plane coordinates, and the other thing I need is to have the correct projection set up. So if I go into the drawing setup under settings, so I'm going to set the projection here to state plane 83, and I'm going to put the zone to California 6, and I'm going to say OK. And then I can go straight to File, Export, Export Google Earth file. And actually there's one other thing I'm going to do. I can view my cut fill color map, so I'm going to turn that on. And I'm going to turn off these labels, so I'm going to freeze those, freeze by pick layer, pick on one of these entities, turn those off, and then I'm just going to go up to File, Export, Export Google Earth file. Okay, I'm going to be able to use the actual 3D elevations that's in this drawing. I'm going to send that to Google Earth. I'm going to bring in the cut fill color map and the rest of these defaults. After I've created this file, it's going to launch it into Google Earth. So I'm going to say OK. And I'm going to call the file demo1. And it's writing it into the Google Earth file format. Say OK. It says select entities. I typed in all enter, so it's going to grab everything onto the screen. And you see, just close that. And we'll see if I got the right projection on here. It zooms in, and there we go. I can zoom in here, and I can see my job. This hill, I'm cutting into the hill and filling this side, and I'm putting in this building with the parking lot going around. And if I uncheck the line work I've brought in, full disclosure, someone's already built this job, but I can see the line work I brought in exactly matches the building that's there now and the parking lot going around. I can even see the swimming pool that we had brought line work in for.